Hello and welcome to the analysis of the Hindu newspaper dated January 27, 2023. In this video, we are going to talk about two important newspaper articles which are going to be very important, very significant for the civil services examination. So let's start this video with this first important newspaper article. Now, this particular newspaper article talks about a space mission of the ISRO, which is Aditya L1. And it also talks about a payload which is known as visible line emission coronagraph. We are going to talk about the Aditya L1 mission. We are going to talk about what is written in this newspaper article and how this particular project is going to be beneficial for the human race. Now, this particular article is important for the GS paper 3, that is achievements of Indians in science and technology, indigenization of technology and developing new technology. Let's first understand the context of it and then we will get back to the main pointers in this particular newspaper article. Now, the ISRO, which is a space organization, right, of India, is planning to launch the Aditya L1 mission by June or July this year. And Aditya L1 is basically the India's first space mission to observe the solar corona, right? So it is going to observe the corona, which is the outside surface of the sun. And apart from it, it is also going to absorb the entire sun, right? This is the basic essence of this particular mission, that is Aditya L1. Now, Aditya L1 mission will be launched by ISRO to the L1 orbit, that is Lagrangian 1 orbit, which is the first Lagrangian point of the Sun-Earth system. Now, why it is being placed there? Because it is the nearest to the sun, and the L1 orbit allows Aditya L1 to look at the sun continuously. This is the basic understanding of the mission we have regarding it, right? And Aditya L1 has 7 payloads in total, of which the primary payload is visible emission line coronagraph. Now, this visible emission line coronagraph is basically going to do what? It is going to observe the corona of the sun, which is the basic function or the basic objective of this particular mission. Now, this VELC, that is visible emission line coronagraph, is designed and fabricated by the Indian Institute of Astrophysics, Bengaluru, and this particular mission has been in collaboration with the Indian Space Research Organization. So the other 6 payloads are being developed by the ISRO and other scientific organizations at this particular point of time. Now, the payload will be able to observe the corona continuously, and the data provided by it is expected to answer many outstanding problems in the field of solar astronomy, and no other solar coronagraph in space has the ability to image the solar corona as close to the solar disk as visible emission line emission coronagraph can. Now, if you are doing it for the first time, this puts India on the forefront of the space race, right? And apart from it, you can image it as close as 1.05 times the solar radius, which is significant, right? And it can also do imaging, spectroscopy and polarimetry at the same time, and it can take observations at a very high resolution or level of detail and many times a second, right? So these are the major pointers regarding this particular newspaper article, and we have observed what is known as Aditya L1 mission. We have talked about the payload which is carrying it is visible emission line coronagraph, which is basically going to study the corona of the sun, right? So this is it regarding this particular newspaper article. Let's now head to the next important newspaper article. Now, this particular newspaper article is regarding the Fukushima wastewater which is going to be discharged. For those who do not know it, Fukushima disaster happened in 2011 after the tsunami struck the nuclear facilities of Fukushima. Now, this has raised a concern. The wastewater of what was stuck, the wastewater, nuclear wastewater, which was stuck in the nuclear facilities of the Fukushima is now being released. Now, this poses some kind of damage to the environment as well, some kind of concerns by the environmentalists as well. So we are going to address all of them. And why is this article important? This article is important for the GS paper 3, that is conservation, environmental pollution and degradation, environmental impact assessment. So let's first understand the context of it, what is the story so far, and then we will understand what are the problems associated with it. So Japan is expected to start flushing 1.25 million tons of wastewater from the embattled Fukushima power plant into the Pacific Ocean this year as part of a $76 billion project to decommission the facility, and the project received the Japanese cabinet's approval in 2021 and could take 3 decades to complete. So the idea, which experts and officials in Japan had floated in 2016, has been controversial for its suspected impact on the water, marine life. Now, if you are going to discharge all of the water into the Pacific Ocean, which is basically nuclear active, then what is going to happen? The life of the marine life, the fisheries are going to be affected by it, and the humans also do consume the fishes, and that is why the humans will also get affected by it. There are chances of getting cancer by it, right? And these are some of the problems regarding it. So in March 2011, after an earthquake of 9 magnitude, a tsunami flooded the Fukushima Daiichi nuclear power plant in Okuma and damaged its diesel generator. This led to the loss of power, suspended coolant supply to the reactors, and the reactors basically became overheated, and you had to basically shut it down. Now, now the nuclear facilities cannot be shut down. These are some of the nuclear reactors which are basically decades old, and they do not have that kind of facility that you can shut it down. So the nuclear reactor kept functioning, and it started producing all the radiations because there was no coolant, and that led to radio material leakage from the reactor pressure vessels and exploded in facilities upper levels, and exposed themselves to ambient air, water, soil, and the local population. And that particular area of Fukushima is basically very contaminated, and there is no life habitation possible at this particular point of time as well. After all of these years, after basically 12 years, this particular problem is still persist, and winds also carried radioactive material thrown up into the air into the Pacific. Since then, the power plant and its surrounding land has been uninhabitable because of the radio waste, and the water that the Japanese government wants to flush from the power plant was used to cool the reactors, and it is also basically rainwater which is stuck there, and it is also the groundwater which the Japanese government wants to flush out. It contains radioactive isotopes from damaged reactors, and thus itself it is very radioactive. And Japan has said that it will release this water into the Pacific Ocean over the next 30 years. So now at this particular point of time, we want to know whether this particular water is treated or it can be treated and then it will be released. Then we will answer this particular question. So the Tokyo Electric Power Company, which operates the Fukushima facility, has said that it has treated the water to remove most of radioactive isotopes, but the experts expect the affected water to poison the fish. This is the main concern by the experts, because you cannot remove all of the radioactive waste from the water, from that particular water which is stuck in the Fukushima facilities. Now this particular discharge can lead to fish getting the cancer, and in turn the humans can also get the cancer out of it. And another problem is that the TEPCO has not removed tritium from the water, because this is very difficult to do, and the tritium is easily absorbed by the bodies of the living creatures and rapidly distributed via the blood. And in 2018, Kyoto News reported that there were other nuclides in the water that the TEPCO's treatment procedure could not entirely remove, and these include isotopes of the ruthenium and plutonium, which are basically very dangerous for the human life. So what are the Japanese options at this particular point of time? So basically, some have asked why the Japanese government can't store the water for the long and then discharge it. And this is because the tritium's life is very short, and the time it takes for its quality to be halved through the radioactive decay is 12 to 13 years. Now 12 to 13 years is the present period of time. So this particular tritium has been some kind of neutralized, right? And the quantity of any other radioactive isotope present in the water will also decrease in this time, and each isotope has its own half-life, and all of the elements present in it, plutonium, ruthenium, all of these particular isotopes are basically will neutralize over a period of time. And that is why the Japanese are taking up this particular option in order to release all of the wastewater from the Fukushima facility. So at the time of the discharge, the water could be very less reactive according to some of the people, right? So this is it regarding this particular newspaper article, and this is it for the day. Thank you from my side. Do like and share the video and subscribe to this channel. Have a good day. Bye.